Real-time code snippet management architecture using Java Swing. This project focuses on improving the developer's productivity by enabling quick reuse of code snippets. In this video, I'll cover the overview, architecture, implementation, and finally advantages and future scope of the project. So this section introduces the basic concepts and the problem we are trying to solve. So first, let's begin with what is Java Swing. So Java Swing is a graphical user interface toolkit which is used to build the desktop application in Java. It provides the components like button, text fields, tables, and menus. In this project, Swing is used because it supports rich user interfaces, it works offline and provides fast interaction. It follows a similar structure to MVC, which helps in organizing the code efficiently. So simply, it helps us to build a responsive desktop application for managing code snippets. So now let's talk about the problem and goal. In real world development, developers often rewrite the same code multiple times. They also waste time searching for the code in chats, old files, or repository. This creates problems like time wastage, inconsistency, and reduced productivity. So the goal of our project is to provide a fast and easy access to reusable code snippets in real time. Now let's understand about the code snippet concept. A code snippet is a small reusable piece of code like a function, query, or API call. Now each snippet contains metadata such as the title, programming language, tags, and description. This helps in organizing and quickly finding the required code. The system provides key features such as fast search based on tags, language, and content, sorting and filtering options, and storage support using MySQL or Neon database. These features make the system efficient and easy to use. Now I'll explain the system architecture and how the components interact. The system follows a layered architecture. First, front-end, that is user interface. Second, service layer, snippet service. Third, repository layer. And fourth, data source layer. Front-end is built using Java Swing and it handles the user interaction. Second, service layer contains the business logic. It processes the requests like search and save. Third, repository layer handles the database operation. And fourth, data source layer connects to databases like MySQL. So the flow is user to user interface, then service, then repository, then database, and then response back to the user interface. So this separation improves the maintainability, scalability, and performance. So this diagram shows how the data flows in the system. When a user performs an action like search, the UI user interface sends the request to the service layer. Now the service processes it, repository fetches the data from the database, and the results are returned back to the user interface. This ensures smooth and structured processing. Now I will briefly explain the implementation details. So snippet service, it is the core component of the system. It is responsible for saving the snippets, searching the snippets, and retrieving the data. It acts like a bridge between the user interface and the database, ensuring that all the operations follow the proper logic. So now I will be explaining about all the codes. So this project is built around a clean separation of concerns and the code logic starts with the Railway MySQL snippet repository class, which handles all the interactions with the MySQL database using JDBC. So when this class is initialized, it receives a data source object and immediately calls the ensure schema method which creates the snippets table if it doesn't already exist. This ensures that the application can run without requiring manual database setup. The table stores fields like ID, title, language, tags, code, and timestamps for creation and updates. The find all method retrieves all the snippets from the database, ordered by the latest updated time, and converts each database row into a snippet object using map row method. Then we have a save method that is designed efficiently using a single SQL query with insert on duplicate key update, which means that it can both insert new snippets and update the existing ones depending on whether the ID already exists. The find by ID method fetches a specific snippet using its UUID, which the delete method removes a snippet from the database. Additionally, the see if empty method checks if the table is empty, and if so, inserts the default snippet like binary search and DFS, depth first search, to provide the initial data. The map row method plays an important role by converting the SQL result data into Java objects and also parsing tags from a new line separated string into a list. So moving into the application entry point, which is the snippet application class, it is responsible for launching the UI and deciding which database to use. It first tries to create a MySQL data source from the environment variables if available. It initializes the MySQL repository and seeds it with the default data. If MySQL is not available, it falls back to the repository, and if no external database is configured, it uses an in-memory repository. This flexible design makes the application portable across environments. The repository is wrapped inside a common interface using the wrapper method like wrap MySQL, which ensures that the rest of the application interacts with a consistent API regardless of the underlying database implementation. The main user interface is implemented in the snippet dashboard frame class using the Java Swing. This class builds a modern dashboard style layout with a header matrices section, a split pane for the snippet library and editor, and a footer. The left panel displays a list of snippets and includes the filters for searching by text language tags. These filters are connected using listeners, and a timer is used to delay refresh operations, slightly improving the performance by avoiding the excessive database calls during typing. The right panel acts as a code editor where the user can input the title, languages, tags, and the actual code. It uses a custom syntax highlight text pane to provide a better coding experience. The UI also includes action buttons such as new, save, delete, and export. So when the user clicks on save, the input data is validated, updated, or updated in the current snippet object and passed to the service layer, which then persists in the database. The delete button removes the selected snippet after confirmation, and the export options also allow to save either a single snippet or a multiple filtered snippets into files, including support for language specific extension or markdown format. So overall, the code demonstrates a well-structured application where the UI handles the interaction, the service layer manages the logic, and the repository layer handles the database operation. It also includes the thoughtful features like automatic schema creation, default data seeding, efficient SQL queries, real-time filtering, and export functionality, making it a complete and a practical developer tool. So here we have is the UI code, as you can see on the screen. So UI is built using Java Swing in the snippet dashboard frame class, and it represents the main dashboard of the application. The layout is divided into three main sections: a header, a library panel on the left, and an editor panel on the right. So the snippet list is displayed using JList with a custom renderer which shows the title, language, tags, and the updated time in a clean format. Also at the bottom there are action buttons like new, save, delete, export selected, and export filtered. And then finally, we have the database code. So as I have earlier told that in this project, the database logic is handled inside a Railway MySQL snippet repository class, which uses JDBC to connect to a MySQL database hosted on Railway. So first of all, I'll pass a data source object and immediately call the ensure schema method. This method runs a SQL query to create the snippet table if it already doesn't exist, and this makes the application self-initializing, so we don't need to manually create the tables. So these are the further database codes that I've used in my project. So overall, the application follows a clean flow where the UI handles the user interaction, the service layer processes the logic, and the repository layer communicates with the database. This separation makes the application scalable, maintainable, and easy to extend. So with this, we come to the conclusion of our video. But before the conclusion, I'll just show you the output of my application. So this is the final output of my application snippet studio. This is a desktop dashboard for managing the code snippets. At the top, we have the header, which is showing the app name and its purpose along with the badges indicating the database connection and the coding support. Below that, the matrices section displays the total code snippets, languages, tags, and the selected items for a quick overview. The interface is divided into two parts. On the left, the algorithm library shows all these snippets with the search, language, and tag filters. On the right, the snippet editor allows the users to create or edit the code with the fields for the title, language, tags, and the code editor. At the bottom, there are action buttons like new, save, delete, and export.